if this is a distribution of x, where x follows the beta distribution of parameters alpha and beta, where x is also in the range of 0 up to 1, where the parameters alpha is greater than 0 and beta as well. We need to find the expected value and the variance. In other words, we need to derive the expected value and the variance of the beta distribution. Let's begin with the expected value. What is the formula of the expected value of the continuous distribution? So this is given by x multiplied by the distribution like that, dx. So integral of x multiplied by the distribution, in this case we have the beta distribution. So once we have this, what we need to do is just to plug in the information that we have. So we have integral there, and we know that x is starting from 0 up to 1. So we say 1 and 0, meaning x is starting from 0 up to 1, and we have x, and we plug in the distribution that we have, which is beta of alpha beta. Then we have x minus 1 minus x, beta minus 1 dx. So from here, what we need to do is simply to take out this because it's a constant. So we are going to say 1 over beta alpha beta like that, integral of 1, 0, and we'll have x here, and x are common, so we can multiply that. So we'll have x alpha plus 1, then we'll have minus 1 like that. 1 minus x, beta minus 1, dx like that. So one thing that we need to do, actually one thing that we need to know so far is that this is the function of gamma. So this thing can be written as well in this form. Gamma of alpha, gamma of beta, over, so gamma of alpha, gamma of beta, and over both thing now. This plus this, beta plus beta, beta, I mean alpha plus beta, like that. So you can put the brackets like that. So this will help us just to know this, or to keep it in mind as we proceed with the calculations. So I just wanted to show you that it can also be written in that form. Well, so from here, what we need to do to proceed is simply to rewrite this into this. So if you have noticed, the 1 and the 1 are cancelling, but I don't want to cancel them because they have changed a bit the function that we have here. So if you want, of course you can cancel them, but you need to show that the function has changed a bit. So what I mean is we will have outside beta alpha beta like that. Then here we are not going to have this function here, but we are going to have a function of this form, alpha plus 1. Sorry, I don't need to put the bracket here. I need to put just a comma. Alpha plus 1, comma beta, like that. So I'm taking this alpha plus 1, then comma beta, like that. So what we need to do from here is to ask ourselves, if this is equal to that, how about this? Well, we're going to employ the same logic, but here we know that 1 is divided by this thing of that form. So what we're going to do is to replace that thing with that form alpha and beta divided by, I mean, gamma of alpha plus beta like that, brackets, like that. So here we're multiplying again with this, but we want to rewrite this into the form like this. So what we're going to do is we're going to start with alpha plus 1, like we did with alpha. We're going to say gamma of alpha plus 1. And we're going to have gamma of beta. And this will divide by summing up these terms, this one and that, or rather that and that. So we'll have alpha plus beta. I want to put the one at first, plus 1 like that. Looks very smart. So when we have this, what we need to do is to make some changes to this. Yeah, even to compute this. Like to change here, when we have multiplication, we know that this will go down and the denominator will go up. So they will swap. Let's do that. So on top we will have open bracket alpha plus beta like that. Then we will have alpha and we will have beta here. Multiplied by here, we need to change something here. So sum of alpha plus 1 is equal to, first of all, what we need to do is to take the parameter out. We say alpha, then we remain with alpha. Actually, this is equal to that. It's one and the same. So the same way we are going to apply to this, but you need to notice something here that can help you. So here, what we are going to do is, since we have alpha plus beta plus 1, we're going to say we take out these parameters. So first, what you need to do is to take out the parameters and make sure that inside you remain with the parameters. If you say that, it's going to be very simple for you as you compute this. So this is equal to that. So we are going to replace this and that. So we will have on top alpha, sum of alpha, of beta, then down we will have alpha plus beta, then sum of alpha plus beta like that. So from here you can notice that this is cancelling with that. Although we can even put that so that you see clearly. And on the other hand, we can see that sum of alpha is cancelling with that. And we can also see that beta is cancelling with that. So on top, just remain with half, this one. Then down, we just remain with that. So we will have alpha over alpha plus beta, like that. So this is equal to the expected value. So we are done with the expected value. This is the expected value of the beta distribution. How about the variance? So let's go on and compute the variance. So computing the variance now, we have second moment now, and also know this. So we just need to plug in the information that we have so far. So this is just what we got. It is just alpha plus 1, close the bracket, then we have alpha plus beta, then open bracket, alpha plus beta plus 1 like that. And minus is here. Then what we had as our expected value is alpha over alpha plus beta squared. So from here, you can notice that this thing here is squared if we distribute the 2. And the other thing that we can see from here is that this is common. So we can factor it out. We can have alpha over alpha plus beta like that. Then what will remain here? Or should I just remove brackets? Look very smart. I want to remove brackets because I want to put brackets to this one here. What will remain? So we will have what will remain. This alpha will go, remain with this here. Alpha plus 1 divided by this. This will move out. Then we'll have alpha plus beta plus 1 like that. Minus, here we say they're squared. So if we move 1, we remain with alpha plus beta like that. So from here, you can just bring these guys outside down. We have alpha plus 1, beta alpha plus beta like that. Then from here, we can just find the common denominator. If you remember that math of finding or making the expression a single term, that one can work here. And you'll pretty have an advantage if you still remember those concepts. So if we say this into that this term into the down term and multiply what, we can get the numerator. But I don't really like that, because I know if I write this, go into the down part, I'll remain with that. What I simply do is that this multiply the other way, and that should multiply the other way. So after you write this, alpha plus 1, like that, put in the brackets, and this alpha plus 1 should multiply this. Alpha plus beta, then out of minus, alpha multiplying this. So out of alpha plus beta plus 1, like that. Then close the brackets. So let's work from here. We can bring just those things out, just write them. We work with the things inside. So if we multiply this, we're going to have alpha multiplied by alpha is alpha squared, then alpha multiplied by beta will be alpha beta. Then we come to 1. 1 multiplied by alpha will be just alpha. Then 1 multiplied by beta will be just beta. Like that. Then here, let me write just things down. Alpha plus beta plus 1, like that. Alpha plus beta, like that. So here we'll have a minus. So this alpha, distributing it, will be this alpha squared. Alpha multiplied by alpha will be alpha squared. Alpha multiplied by negative alpha multiplied by beta will be negative alpha beta. Then negative alpha multiplied by 1 will be negative alpha, like that. You can extend that. So here we will have this thing coming just down as beta, like that. Then here we will remain with let's just cancel. That cancels with that. Then you can also see this one cancelling that. Then this one as well. Sorry, it's this one cancelling with that. So this one is still there. You can check. This one, you see, is still there. We have that. So we're remaining with just beta, like that. Then this divided by alpha plus beta plus 1, like that. Then alpha plus beta, like that, as our denominator. So we can separate, we can multiply here. If we multiply the numerators, we will have alpha beta. The denominators, this is common with that, so we can just square this. So we will have alpha plus beta plus 1, then alpha plus beta squared. And this is simply equal to our variance of the beta distribution. So that's it for this video, guys. Thank you so much for watching this video. Please remember to subscribe for more videos like this.